Hi, my name is Bailey Hayes, and I'm really excited to be your host for today's first Bytecode Alliance community meeting. We have an action-packed agenda. I'll go over what these meetings are, a little governance update, and we'll hear some project updates from Wasmtime WAMR, and also some overarching work that's being done as part of the W3C and in the Bytecode Alliance for WASI and the component model. So first up, what is our community stream? Well, it's our first one. Every month, we're going to aim to run a stream to get updates from all of the projects across our community, highlight recognized contributors, and if we have it together, we can run a live demo. We don't have live demos this time, but next time, I really hope we pull one out. If there are any questions during the stream, you can ask in the YouTube comments, or I feel like it's a little bit easier for your questions to live longer if you post over in Zulip. This QR code, if you scan that, it'll take you over to our Zulip channel for our community stream. And all of these slides will be available right after the call. So if you're not familiar with the Bytecode Alliance, our mission is to be the technical foundation for the WASI and component model, to build a software foundation and tools that everybody else can build on top of. But we don't want to be the only game in town. All of our sources open, and we encourage contributors from all across the world, and you don't have to be part of a member organization to contribute. Now, a little governance update. Till's traveling right now, so he wasn't able to give a governance update today, but next month he's going to give you a much broader view of how a lot of the inner workings of the Bytecode Alliance work. But I thought now would be a really great time to announce that we have a TSE chair, Nick Fitzgerald. Now, we three were voted to be part of the TSE after the Proto TSE, which special thank you to our Proto TSE for serving for the past year. This group was nominated by our recognized contributors. And so up first, Nick Fitzgerald, he is our TSE chair. Our at-large director is Till Schneiderite, and I am the TSE director. So let's go ahead and get out of the boring stuff and check out some of our project updates. Now, some of these are going to be pre-recorded. That way we can get people to participate from all across time zones. And that's why our next monthly community meeting is going to flip-flop time zones and be later in the day my time to accommodate others. I'm going to play Shin's video now.
Hi, nice to meet you. I'm Xin Wang. It's my pleasure to give you a short introduction about WebAssembly Micro Runtime project. We will give an overview about WAMR, the community achievement in 2022, and the roadmap for 2023. WAMR is a runtime implemented in C that loads and executes WASI modules in either interpreting, JIT, or LT compiling mode. WAMR was created by a few Intel engineers and donated to Bytecode Alliance in 2019. Today, WAMR has built a very healthy community. The WAMR Technical Steering Committee was established, and currently the members come from Intel, Amazon, Sony, Alibaba, and Xiaomi. And we hope Siemens will send some rep to TSE soon, since they have been actively contributing to some core features like exception support. So far, surprisingly broad usage happened on WAMR, even though many are out of our original imagination. The usage areas cover trusted execution for Intel SGX and the function as a service, cloud edge workload orchestration. In the big data, WAMR is used for building user-defined secure function for database. On the devices, WAMR has largely adopted by many commercial products. In blockchain, PDO and end-chain use WAMR for smart contract. WAMR is one of the upstream proxy engines in the envelope service mesh. We're glad that WAMR was used in Sony's product and Xiaomi's IoT devices. Thanks to the community contributors, WAMR has achieved amazing achievements in the last year. FastJIT was introduced for providing extremely fast compilation. Based on the FastJIT, the dynamic tier-up from FastJIT to LVM-JIT on the fly can greatly help the usages like FAST to achieve both quick code start time and high execution performance. The GC for the earlier proposal was implemented on the interpreter, but it is broken now for the latest GC proposal to support better experience in developing Watson apps. The source debugger and the VS Code extension are further improved. Bindings for Python and Go now are supported. The Watson support for trusted execution environment is further enhanced for remote attestation. With IntelliSJAX, the user Watson function running in third-party cloud can be fully trusted and confidential. Full POSIX socket API now is supported. WASI AN is implemented, and the WASI thread is a work in progress. Sony and Xiaomi contributors have done a lot to make WAMR greatly enhanced for non-tax system and embedded environment. In the service mesh, we also supported the ahead-of-time compilation mode for Envoy proxy. The WAMR just had a project TLC meeting, and the 2023 roadmap was defined. We will continue to improve the performance and get the latest GC proposal support on both interpreter and JIT. Siemens team has been working on the exception support for WAMR. The SMD support for the FastJIT is under work by the community as a part of a big mission to grow the developer base. We are exploring native supporting TypeScript to WebAssembly. The basic idea is to use WasmGC and the static type information for converting as much as possible to WebAssembly at compiling time. And the remaining part, like any type, can be supported in a small runtime. We hope the user TS code can follow 80-20 rules to use static type for 80% of the code, so we can also achieve some performance gain compared to the current GS compilation approach. Component model is a very important feature. The proposal has come to a milestone. We plan to visit this proposal in the middle of the year and work out the plan to support it. Debugging support for multi-threading is also wanted feature. We hope this can be done in this year. Thank you for your interest and time. That's all for the WAMR today. We look forward for your showing up in the WAMR community. Thank you. Bye.
Thank you, Xinwei. That was an update from one of the WAMR technical leads. Next up, we're going to listen from Nick Fitzgerald for Wasmtime.
Wasmtime is a fast and secure runtime for WebAssembly. We just released version 5.0. For anyone who's unfamiliar with Wasmtime's release process, it was originally designed via a Bytecode Alliance RFC. We cut a new release every month, and we patch the latest 2 Wasmtime releases for security and correctness bugs whenever we have them. The new 5.0 release includes the Wasmtime component bindgen macro. This generates glue code for Wasmtime embedders to help them consume WASM components. Note that oh my gosh, all right, starting over from the top. Ignore everything before this. Wasmtime is a fast and secure runtime for WebAssembly. We just released version 5.0. For anyone who's unfamiliar with Wasmtime's release process, it was originally designed via a Bytecode Alliance RFC. What we do is every month we cut a new major release, and we patch the latest 2 Wasmtime releases for security and correctness bugs whenever we have them. The new 5.0 release includes the Wasmtime component bindgen macro. This generates glue code for Wasmtime embedders to help them consume WASM components. Note that the component model and WIT is still in heavy development, so this should be considered a preview at this time. On the main branch, CraneLift, which is Wasmtime's code generator, turned on egraph optimizations by default. This work is helping us run WASM code faster and enabling verification in the future so that we can prove the correctness of our optimizations and you don't have to worry about miscompiles. That's all for Wasmtime this month.
Thank you, Nick. Now, up next is Dan Goman, who I'm going to add, and I'm going to remove myself.
All right, thanks, Bailey. So WASI is the WebAssembly system interface, and the system interface is typically referring to APIs that are provided by a host environment. WASI is standardized by a subgroup of the W3C WebAssembly community group, which is the standards body that standardizes WebAssembly itself. The basic vision for WASI is to take the things that are really great at WebAssembly itself and extend those strengths to the domain of APIs. So WebAssembly is a great bytecode. It has great portability properties, support for security, multiple languages, and virtualizability. We want to take these great properties of WebAssembly and bring them to the space of APIs. WASI today is called Preview 1. That's the version we're all using today. It's kind of the thing that we have, it's shipping in production, and people are using it in various contexts. Lots of languages support it. It has support for languages like C++, Python, Ruby, C#, Rust, Go. Lots of different languages have support for WASI at this point, and many different languages and engines also have support. Wasmtime and WAMR both have WASI implementations, and others do as well. And WASI Preview 1 is what actually launched the subgroup that's kind of got us going here. But at the same time, Preview 1 has limitations. It's a very C-oriented API, very low level, which makes it kind of a weak point for our multiple language story if you have to be a C or C-like language to be able to talk to it. Sockets in the WASI Preview 1 are not well supported. There are some features in the standard, and there's some things you can get in various engines, but overall the situation is not very good. Virtualization within the Preview 1 timeframe is very difficult, and many users end up basically doing virtualization in the host layers instead of doing it in the WASM layers. And the same thing with composition. Many people are basically doing composition of putting together multiple WASM programs by linking together with various host kinds of glue instead of having WASM directly talking to WASM. So we want to fix these things. And we know that Preview 1 has taught us a lot. It's kind of gotten to us to the place where we are now, and it's showed us, what WASI is and what we want WASI to be. So we've learned a lot of lessons, and we've incorporated many of these lessons into the component model. And we're taking many of these lessons and bringing them forward into a new iteration of WASI, which we're calling WASI Preview 2. The headline feature for WASI Preview 2 is that it's built on component model tooling. This gives us a really great foundation to build on. It's a much better base to work with in terms of describing APIs. We get a much richer language with many more types of features, and just many more features overall. And one of the big things that we get out of this is it gives us enigmatic bindings in many different source languages. So we're no longer restricted to a C, like a very low level C, like APIs. We can have APIs that many different languages can talk to directly. WASI Preview 2, we're building in support for sockets, so that'll have the typical listen and connect, the typical features that people are expecting from sockets is going to be built in from the beginning. One of the big goals for WASI Preview 2 is to really leverage the strengths we have in the component model. So we want to build in support for virtualization, and we want to have WASI be composable, and we want to be able to support worlds. Yeah, and I don't know what's going on with my light. I apologize for the light stream. I'm not sure. I guess I'm on the sunrise side of the house here. Support for worlds will be really important as we start looking at going beyond POSIX. So WASI Preview 1 is very much focused on sort of a POSIX-like feature set, with file systems kind of being the main focus thing. But as we looked at what we want, what people will sort of stepping forward interested in WASI want to do with it, people want to go a lot of places that are just where POSIX goes. So we want to do things like the WASI Cloud APIs, like WASI Key Value, WASI Messaging, WASI HTTP Proxy. And worlds and the component model tooling is really going to help us keep that all manageable. So a quick overview of some of the things that are going on today with WASI Preview 2. So we're working on building a prototype, which includes a Preview 1 to Preview 2 converter. This can convert not all at this point, but many Preview 1 binaries, WASM binaries, into Preview 2 binaries that can be run on a Preview 2 engine. We're also working on building a Preview 2 host implementation that can run within Wasmtime at this point to be able to have a full sort of end-to-end tool chain where you can produce a Preview 1 binary, convert it to Preview 2, and then run it on a host to make sure that it all works. There are also some language tool chains that are starting to experiment with Preview 2, talking to it directly instead of going through the polyfill. And then finally, I'm building some demos based on Preview 2 for an upcoming WASM.io talk in March. So sort of the goal is to have like an end-to-end cool things we can demo. One of the big activities right now is that we're working on stabilizing the APIs. WASI tends to sit at the very bottom of a stack of lots of different things people want to do. And so we're really working on getting to the point where these things don't have much churn at this point so that people up above it don't have to deal with as many changes kind of going on in the lower levels. So we're working on stabilizing the APIs. And we're also working on setting the stage for Preview 3 in the future. We think that now that we can look ahead to where we think Preview 3 is going to be, we can make some changes now to make sure that we get a good place to have a smooth transition in the future.
All right. Thank you so much, Dan. Something else that I'd like to plug here is that you've been doing some pretty cool live coding streams. What is your Twitch handle for that?
It's not a Twitch handle, it's a YouTube stream.
Oh, YouTube stream, sorry. Just like this one.
Yeah, I can paste it into this thing here. Hopefully you can put that out there where it needs to go.
Yeah, I'll do that. Cool. Thank you, Dan. And I love watching all of your work. Now, next up, we're going to hear an update from Luke Wagner on the component model.
Hello, everyone. This is Luke Wagner, and I'm going to be giving a brief update on the component model. So you can think of the component model as having 4 big-ticket features: parametric linking, high-level value types, resource and handle types, future and stream types. And I don't have time to go into each of these, but if you're interested, you can click this link in the slides and watch a video that kind of motivates and describes each one of these. I'm just going to talk about the implementation status. So in Wasmtime, we've got mostly fully implementations of these first 2, linking and value types. On the producer toolchain side, there's low-level foundational tools that target and produce linked components, and then there's like a high-level tool, cargo component, for providing kind of a easy developer experience for just build me a component from Rust. And I expect there'll be many more tools like this for all the different language ecosystems coming that build on these foundational tools. And then for value types, in WIT-Bindgen, they're the core of it, they're implemented. But of course, there's also all the different language binding generators for all the different languages that are in various states of progress. So in the guest language side, so this is code compiling to run inside as WASM inside of components. The languages we're aware of are Rust, C, Java using TVM, Go using TinyGo, and JavaScript using SpiderMonkey. The host binding, so this is the languages used to embed and run WASM from a host system. The languages bindings we're aware of that are being developed are Rust, Python, and JavaScript. And kind of just focusing on this last one, the JS component tools, it's a pretty interesting tool for 2 reasons. One is that basically this is our browser node polyfill. So the way it works is it takes the components and then compiles it to JavaScript glue and core WASM 1.0 that runs in browsers in Node today. So this is like our polyfill, and it basically works, running components on modified browsers. And then the even more delightfully inceptive fact about it is that JS component tools is itself a component that polyfills itself so it can run in unmodified nodes. So you can just npm install JS component tools and go to town doing various cool component-y things without having to install any other toolchain, which is really awesome. There's also been a lot of fantastic progress and hard work on WIT, and particularly fleshing out this new world concept. So if you're not familiar, to give a recap also from this video, so we have got lots of different interfaces that describe all the different types of functionality that the host may want to expose to components, things like sockets and file systems and HTTP and message queues. And there's going to be a lot of these and more over time, that's the point. But no one host should be required to necessarily implement all of them because there's like going to be a bunch. So we need some other concept to kind of describe collections of them that will be implemented by certain kind of families of hosts so that we can when I'm producing a component, I can even know what's available to me. And to capture this, we have this concept of worlds. So just as an example world, the world that's the most developed, that's the farthest along, is the CLI command world. And this one kind of describes a traditional sort of POSIX CLI command environment. And it says when you run in this world, you get to import things like sockets and file systems and logging, and you can export like a traditional main. And that's totally different than the world that describes, let's say, a database UDF, like I was presenting in the last WASI meeting, where it's a lot more kind of like restricted in what you have available as imports. You don't get a file system or sockets, and you export something kind of SQL specific. And in an HTTP proxy, you're importing HTTP and config and logging, and you're exporting your, HTTP. So it's like HTTP going in and out. And the cloud service can import all sorts of great things that let's say the DS Labs are working on and proposing in the WASI standards. And there'll be tons more of these worlds that get defined over time that can describe different collections of interfaces. So there's two interesting parties here that care about worlds. From a platform vendor perspective, I'm saying I'm going to support this world by implementing its imports, with like native code that I provide to the running WASM, and calling its exports in response to some like external native event, like a request arrived. And then kind of dually, from the component author's perspective, I target a component by calling its imports from core WASM, and then implementing the exports that get called by the host. So you can think of this world as basically being like a higher order sort of interface that sits in between platform vendors, component authors, and says like, okay, what can I expect and what do I have to provide? And so there's been a bunch of progress on this to make this real, because in that presentation it was more of a sketch. So this means things like compiling worlds that you can write in WIT, first letting you write them in WIT, and compiling them to ultimately binary component types. And so component types are this like fully, very precisely defined thing that's like implemented natively in the runtime. And so what we can do is say this world corresponds to this component type, which means if you target this world, you'll get a component that has this type or a subtype, which is a very useful mapping. It makes it very precise what we're talking about. And then plumbing this concept of world through the whole WIT pipeline to be this kind of unifying theme. And what this has done, is resolved a lot of longstanding like kind of type sharing issues of when are two things the same or they're different, and how do I achieve one or the other, what's the default, and all this type of stuff. So this has been a really helpful development. And also, as part of this, we've been working on defining what a WIT package is. And so the idea is a WIT package is a collection of interfaces or worlds that you want to kind of define together. And WIT packages can have dependencies on other WIT packages. And that kind of makes them the ideal unit of standardization and sharing, like via like a registry, like a Bytecode Alliance registry. And so this lets us finally kind of start for developing WASI as a modular set of interfaces that are in like different WIT packages instead of this one kind of monolithic thing, which is great. This is like what we've been wanting to do also from the beginning. And so this, this work has been implemented in the core tools, and it's making its way propagating outward. And from what I hear, it should be done pretty soon. And so what we'll be working on next is making these resources and handles real. That means implementing them in WIT, Wasmtime, and the producer tools over the next few months, hopefully. And then using them as soon as we can in WASI Preview 2. So we can leverage handles to have fine-grained isolation of capabilities and have virtualizable interfaces that we can implement with components, both of these being original WASI goals that we'll finally get to realize. And so if you're interested, you can check out the low-level design in the spec repo. I've got links here to the both low-level assembly component model level explainer and also what this would look like in WIT. So that's it for me. Thanks.
All righty. Thank you very much, Luke. I thought that was a really wonderful overview. I do recommend folks check out Luke's keynote that he gave at the last WASM Day conference. I thought that was a really wonderful in-depth overview of what the component model is. We are getting a few questions in chat, so I'm going to jump us over to a little bit of Q&A. I actually had a similar question last night when I was first aware of the WAMR team working on this very cool TypeScript POC. And so this is from Ralph. He's our, I guess, resident I'm going to call him a troublemaker, resident troublemaker. I think everybody is very interested in this problem. I'm seeing lots of different approaches really across the Bytecode Alliance for how best do we take JavaScript and make it work with a component model, but also work within our WASM runtimes. I think that's something that just, the greater software community as a whole really wants. And so Ralph asked, hey, where do I reach out? Well, the default answer for that is to hop on the Bytecode Alliance Zulip. There's a WAMR channel there. I think that's a really great place because you can post there and everybody else can see your question, because I think there's probably a lot more people that want to jump in and learn from this. I'm just going to pull this one up too. Because this is the whole point of this, so that you can see all the different things that are happening across the community. This was, kind of a short version of the stream, but I really appreciate everybody watching. I put this initial version of the agenda over in the Bytecode Alliance meetings repository. I think going forward, if you want to get things added to the agenda, create a PR there, and we'll work it in. Thank you very much. I am going to pause for a little bit just in case we have any other questions coming in. And I do want to say that we actually do have some of our speakers here online, and I can drop them in if you'd like to ask them any questions live. Okay, I think we should end on that note. Thank you, everyone. And one more question. Hey, where are the slides? Well, I was editing the slides right up to this meeting, but I will post them in the same repository that I just mentioned, the Bytecode Alliance /meetings repository, and I'll add it within the community folder there. And that will be a superset of everybody's slides. So everybody shared their slides with me, but they also, I don't know if you could tell, shared a pre-recorded video. That's to make it kind of level the playing field for everybody from different time zones can, kind of have the same experience in presenting live. So I will drop that in. Oh, hey, Dan, it looks like we actually have a question for you. Are you ready to come on stage?
Yes, I am.
Let's see. Here's your question. Oop. What's the line between Preview 2 and Preview 3 for WASI?
Yeah, so this is not really officially planned yet, but like the rough idea that's kind of emerging is that the async features of the component model, so support for async streams and features, look like they're going to need some more time to really flesh out in terms of the design and the tooling. And so Preview 2 is sort of targeting sort of this pre-async design where we don't use the async features of streams and handles. And actually what we're currently building is a sort of non-async version of streams in WASI as handles and resources. So that's really expected to be the big difference. The cool thing about that, it means that the core functionality, like the what can you do, should be the same largely. Obviously we can add things and we can always make changes. But the goal is that a lot of functionality we're deploying now between Preview 2, it should just be compatible with Preview 3. And Preview 3 will just add, now you have new APIs that can also be async, which will be great.
Okay, so there's a little bit of delay between what we're saying live on the stream and then the questions coming in. So Dan, I'm going to keep you up for just a little bit in case other people want to ask. But let me repeat what you said in kind of like my lamest terms. That when we're building with WASI Preview 2, and I build something with it. I'm using the component tool, so that means I'm using WIT. But the thing that comes out, like once I build directed for WASI Preview 2, is that still just a plain old WASI Preview 2 model? Module, I should say. Is the binary format WASI WebAssembly binary format, or is it a component model binary format?
What initially comes out of the tool is a core WASM module. You might call it plain WASM module, so it's not component model binary format. And then we have tools that take that and sort of wrap it up in a component and make a component binary out of it. So both forms can be produced.
Both forms can be produced. That's really great. So that means Preview 2 takes us pretty far. I know at one point we were thinking that it might not take us as far, right? We were initially thinking like, hey, let's just get it to working with existing WASI, and so existing WASI runtimes can work with this. But that gives us a really good foundation to build. So when you look at the difference between Preview 2 and Preview 3, maybe at an even higher level, what would you say is like the one key defining difference between the two?
So Preview 3, the big idea that people had behind Preview 3 is that will be where we introduce the async features of the component model. So async streams, async features are the really big deal there. So those are going to take a little longer. We don't have time to get them into Preview 2. Preview 2 will release without them. It has its own sort of synchronous version of streams to get us the sort of part of the way there. And then in the future with Preview 3, we'll add the async streams and async features.
Great. Thank you so much, Dan. So we have another question here about, more disappointment that we didn't have an update for the registry work. And we were going to do that. And so we're going to have a focus time for that next month. So next month, the agenda items that I already know of is a deeper governance update from Till, WAMR, and also Crane Lift from Chris. So we'll give, kind of that initial like, hey, what are these different projects and what are their project updates? And then at that point, we can kind of have a monthly cadence of like very succinct updates. And yeah, thank you. I'm glad we answered that question. So we still have kind of, a little bit of delay. So I'm going to just kind of hang and do the popcorn roll because I want to be able to answer everybody's questions as they come in. Thanks, Ralph. You're becoming my favorite commenter. Not that you weren't already my favorite person in general, but I love the engagement. Okay, I'm gonna call it. Unless anybody wants to say any final words. Yeah, sounds like we're good. Okay, well, thank you everyone for watching. Please tune in on February 28th.